Good morning, everybody. Today I will discuss properties of chi-square distribution. Already I was explained two properties in chi-square distribution. Third property: if chi1 square and chi2 square are two independent chi-square variates with n1 and n2 degrees of freedom respectively, or u is equal to chi1 squared by chi1 square plus chi2 square, and phi is equal to chi1 square plus chi2 square are independently distributed, and u is a beta of or beta variate of n1 by 2 n2 by 2 variates, and phi is chi2 square variate with n1 n1 plus n2 degrees of freedom. The proof of the property or solution of the given property: we know that chi1 square and chi2 square are two independent chi-square variate with n1 and n2 degrees of freedom. Now, the joint probability differential is given by dp of chi1 square chi2 square is equal to dp1 of chi1 square dp2 of chi2 square. Already you know the probability density function of the given distribution, that is dp1 of chi1 square chi2 square is equal to 1 upon 2 raised to n1 by 2 into gamma of n1 by 2 e raised to minus chi1 square by 2 into chi1 square raised to n1 by 2 minus 1. Similarly, chi2 square 1 upon 2 raised to n2 by 2 gamma of n2 by 2 e raised to minus chi2 square by 2 chi2 square raised to n2 minus 1 upon 2 degrees of freedom, that is equal to take 1 by 2 raised to n1 plus n1 plus n2 divided by 2 gamma of n by 2 gamma of n2 by 2 into e raised to minus 1 by 2 into bracket chi1 square plus chi2 square into chi1 square raised to n1 by 2 minus 1 chi2 square raised to n2 upon 2 minus 1 d chi1 square d chi2 square. Now let us transformation u and v. We get u is equal to chi1 square upon chi1 square upon chi1 square plus chi2 square, and phi is equal to chi1 square plus chi2 square already given in statement. This implies chi1 square is equal to u phi is equal to u plus chi2 square, or phi minus u is equal to chi2 square. Therefore chi2 square is equal to phi into bracket 1 minus u. How to this consideration? I know, consider u is equal to chi1 square upon chi1 square upon chi1 square plus chi2 square, that is u phi is equal to chi1 square plus chi2 square, that is chi1 square that is q by chi1 square plus chi2 square is nothing but phi. That is why chi2 square is equal to phi into bracket 1 minus u. Now using the Jacobian transformation, j equal to modulus of chi1 square with respect to u, chi1 square with respect to phi. Similarly, chi2 square with respect to u, chi2 square with respect to phi. That equal to, what is chi1 square u phi with respect to u is there, that is v. Chi2, what is chi1 square u phi with respect to phi is, that is u. Next, chi2 square is equal to phi into 1 minus u is there. Differentiate with respect to first u, that is phi take inside the bracket, that is minus u into phi, that is why minus phi. With respect to phi, that is 1 minus u, that equal to using the determination, that is phi into 1 minus u plus minus into minus plus u phi, or that equal to phi minus v plus phi, that is equal to phi, that is called Jacobian J. Now the probability differentiation of given dg of u is equal to 1 upon 2 raised to n1 plus n2 upon 2 gamma of n1 by 2 gamma of n2 by 2 into e raised to, what is e raised to, minus chi1 square by 2, that is 1 by 2 into bracket u phi, plus chi2 square is there, phi into bracket 1 minus u, complete the bracket, that is u into phi raised to n by 2 minus 1 into phi is there, phi into 1 minus u whole bracket raised to n2 upon 2 minus 1. Jacobian J is phi into du dv, that is equal to 1 upon 2 raised to n1 upon n1 plus n2 upon 2 gamma of n1 by 2 gamma of n2 by 2 into that simplification e raised to minus phi by 2 into u phi raised to n1 by 2 minus 1 into phi into bracket 1 minus u whole bracket raised to n2 upon 2 minus 1 phi into du dv, that equal to 1 upon 2 raised to n1 plus n2 upon 2 gamma of n1 by 2 gamma of n2 by 2 into phi raised to e raised to minus v by 2 into u raised to n1 upon 2 minus 1 into 1 minus u n2 upon 2 minus 1 into phi raised to n1 by 2 minus 1 plus n2 by 2 minus 1 plus 1 du dphi, that is Jacobian J is equal to phi is there, that is why phi raised to n1 upon 2 minus 1 plus n2 upon 2 minus 1 plus 1 du into dv. Any confusion, ask in personally. Now dg of u phi is equal to e raised to minus phi by 2 into u raised to n1 by 2 minus 1 divided by 2 raised to n1 plus n2 upon 2 gamma of n1 by 2 gamma of n2 by 2 into 1 minus u raised to n2 upon 2 minus 1 into phi raised to n1 plus n2 upon 2 minus 1 du into dv, that equal to the transformation, the that equal to gamma of n1 plus n2 upon 2 into 2 raised to n1 plus n2 upon 2 gamma of n1 by 2 gamma of n2 by 2 u raised to n2 upon 2 minus 1 1 minus u raised to n2 upon 2 minus 1 into e raised to minus v by 2 into phi raised to n1 plus n2 upon 2 minus 1, that divided by gamma of n1 plus n2 upon 2, that is gamma of n1 plus n2 upon 2 both are cancelled. Next dg1u is equal to dg2 phi, since the joint probability differential of u phi is the product of respective probability of u and phi are independently distributed, that is why dg1 of u is equal to 1 upon beta of n1 by 2 n2 by 2 u raised to n1 upon 2 minus 1 1 minus u raised to n2 upon 2 minus 1 du, which follows beta first kind of n1 by 2 n2 by 2. dg2 of u is equal to 1 upon 2 raised to n1 plus n2 upon 2 gamma of n1 plus n2 upon 2 into e raised to minus phi by 2 phi raised to n1 plus n2 upon 2 minus 1 d phi. It follows chi-square distribution with n1 plus n2 degrees of freedom. Here beta is distribution of the first kind, that is beta 1, that is given by f of x is equal to 1 upon beta 1 u phi x raised to u minus 1 into 1 minus x raised to u minus 1 du. Already you know in second semester. Similarly, fourth properties. What is fourth property? Let x1, x2, so on xn be a random sample from be a normal population with mean mu variance sigma square. Here there are three cases. One, x bar follows normal with mean mu variance sigma square. Second, summation I is equal to 1 to n xi minus x bar divided by sigma I follows chi square n minus 1 degrees of freedom. Third, summation xi I is equal to 1 to n divided by n and ns square upon sigma square is equal to summation into bracket xi minus x bar upon sigma I bracket square or independently distribution. The solution of this property, the joint probability differential of x1, x2, so on xn, dp of x1, x2, so on xn is equal to 1 upon sigma into root 2 5 whole raised to n e raised to minus 1 upon 2 summation I is equal to 1 to n xi minus mu upon sigma I bracket square, that is x1, x2, so on xn lies between minus infinity to plus infinity. Since PDF of normal distribution is known, 1 upon sigma into root 2 5 e raised to minus 1 by 2 xi minus mu upon sigma whole bracket square, already you know in distribution chapter. Let us transfer to the variables yi or I is equal to 1 to n by means of the linear orthogonal transformation, that is y is equal to a into x. Now let us choose in particular a11 is equal to a12 so on a1n, that is equal to 1 by root n. This implies yi is equal to 1 upon root n into x1 plus x2 plus so on plus xn. Therefore, y1 is equal to 1 upon root n into summation I is equal to 1 to n xi, that is equal to n into x bar upon root n. You know the mean or arithmetic mean formula, x bar is equal to summation xi divided by n or n x bar into summation xi. This is equal to n is consider root n into root n. Root n into root n divided by x bar divided by root n. Root n cancel, that is yi is equal to root n into x bar. It can be easily seen that the about choice that a11, a12, so on a1n or satisfies the conditional for orthogonal, that is summation a I j square j is equal to 1 to n, that is equal to 1. Since the transformation is orthogonal, we have summation I is equal to 1 to n yi square is equal to summation xi square I is equal to 1 to n, that equal to summation I is equal to 1 to n xi minus x bar whole square plus n into x bar square, that equal to summation I is equal to 1 to n xi minus x bar whole square. N x bar square is nothing but y1 square. You know already y1 is equal to root n into x bar. That is equation number 1. Summation I is equal to 1 to n yi square minus y1 square, that is equal to summation I is equal to 1 to n, take y1 square LHS side, xi minus x bar whole square. Summation I is equal to 1 to n yi square is equal to summation I is equal to 1 to n xi minus x bar whole square. Since y1 square plus y2 square plus so on plus yn square minus y1 square cancel, only summation I is equal to 2 to n yi square, and also summation I is equal to 1 to n xi minus mu whole square, that equal to summation I is equal to 1 to n into bracket, add and subtract x bar here, xi minus x bar plus x bar minus mu whole square, that is equal to, here xi minus x bar is a term, x bar minus mu term is b term, using a plus b whole square formula. Summation I is equal to 1 to n xi minus x bar whole square, that is a term, plus and also take summation inside b term. Summation I is equal to 1 to n is nothing but n, because x bar minus mu is independent of summation n into x bar minus mu whole square, that is b square, plus product term ab 2 into x bar minus mu into summation I is equal to 1 to n xi minus x bar. This is equal to summation I is equal to 1 to n xi minus x bar whole square plus n into x bar minus mu bracket square, since product term becomes 0. By equation 2, we have summation I is equal to 1 to n xi minus mu whole square, that is equal to I is equal to 2 to n yi square plus n into bracket x bar minus mu whole square. Now using the theorem of Jacobian transformation, or modulus of j is equal to plus or minus 1, thus the joint differential of x1 x2 so on xn transform to dg of x1 x2 so on xn, that is equal to 1 upon sigma into root 2 phi raised to n e raised to minus 1 upon 2 sigma square into bracket summation I is equal to 2 to n yi square plus n into bracket x bar minus mu whole square into Jacobian j dg, that equal to 1 upon sigma root 2 phi bracket raised to n into e raised to minus 1 upon 2 sigma square summation I is equal to 2 to n yi square plus n into x bar minus mu whole square d r into dy1 dy2 so on dyn, that equal to 1 upon root 2 phi sigma square root of n by sigma into bracket e raised to minus n by 2 xi minus mu whole square into dx bar 1 by sigma root 2 phi raised to n minus 1 e raised to minus summation I is equal to 1 to n yi square dy2 so on dyn. Thus x bar and summation I is equal to 2 to n yi square equal to I is equal to 1 to n xi minus x bar whole square. This is nothing but ns square, since s square is equal to 1 upon n summation I is equal to 1 to n xi minus x bar square, where s square is the sample variate. This distributed respectively, x bar follows normal with mean mu variance sigma square by n, and yi I is equal to 1 to n are independently distributed, that is the sum of the squares of n minus 1 is independent standard normal variate is distributed chi-square variate with n minus 1 degrees of freedom. Thank you.